Hey everybody, welcome back. We are getting into part 4 of our series, which means we only have 2 chapters left. Part 4 is dealing with databases and software development. Now, the difference between the U51 exam and the current U61 IT Fundamentals CompTIA exam is that chapters 14 and chapter 15, databases and developing and implementing software, were not part of the U51 exam. So these are basically brand new sections and brand new topics that were introduced into the U61 exam for the IT Fundamentals plus U61. So again, this is brand new. You did not have this. If you took the U51, you'll see that this is totally different. So we're going to be covering our last part, which is part 4, chapters 14 and 15. This video is focusing on chapter 14, which is understanding databases. Now, in this chapter, our objectives is that we will explain database concepts, we will be able to structure a database, and also create and manage databases. Now, first thing that we need to ask ourselves is, what is a database? Now, a database is used to store data in an organized manner for quick searching and quick retrieval. There are text files that we will be storing these databases. They are called flat file storage. Now, databases uses tables to store data. A table has 2 parts to it. You have rows and you have columns. But a table is a database storage structure that defines how the data is stored. And there's always going to be using labels so you know what is what. Now, we have 2 types. We have records and we have fields. Records are a stored item within a database consisting of 1 or more fields. And it's also called a row. So a record is the line that goes straight across our database. But a record is a row. So just remember the R and the R go together. Record and row. A field is a specific type of data that is stored. There's usually a maximum length of 10 characters, and this is considered the column. So think about your employees, or think about a list of friends that you have, and that each one of your friends is considered a row or a record. So you might have Adam and Bill and Kurt and Dan. Each of those have those. Each of those are considered a different row or a record of that table. And then what we talk about with each one of those persons, maybe it's whether they went to a certain high school, or whether they are married or not married, whether they own or rent a house. All of these extra pieces of information about those people are considered fields or considered columns, and then you could put in the different information on that column. Searching or making a query or querying can apply to any field in that record. So we don't talk about searching or finding data. We're talking about making a query when it comes to tables. Now, a database table structure can really have 2 different ways of doing it. You can have a single field table structure, or you can have a multiple field table structure. I put some examples on this slide over here. If it's a single field, all records are stored in one field, and it's not very easily searchable. If you look over on the right-hand side graphic, you see data stored in a single field. We talk about the field as a musical instrument, and the sample data talks about Gibson, guitar, A456-899. They have all this different information about the musical instrument, but we don't know what that information relates to. We don't know what those numbers mean. It's just kind of a bunch of stuff that are thrown together. So that's considered a single field table structure. It's hard to search when you don't know what you're looking for. You can also have a multiple field table structure, which is all records about an item are stored in multiple fields. This makes it very easy to search. Instead of just saying musical instrument, as you can see here, they have it broken down. They have the category of the musical instrument, the make of the musical instrument, the model, the color, the wholesale cost, and so on and so forth. And notice there's a lot of fields. There's a lot of different information here, which is great. It makes it easy to search it. If you're looking for a certain inventory ID, you can then search for those. If you're looking for a certain model, you can search for that. Now, whenever we have a lot of information, we want to make sure our database is scalable, and the scalability of this database is important. Databases should be able to grow to fit needs. As you have more records or more fields, you should be able to grow this information or grow this table so you can easily do it. And you can grow it one of two ways. You can either scale out or you can scale up. Now, scaling up is considered vertical, makes sense, going up vertical. That's when you're adding more computer power to the actual host computer. If you have one computer and you want to make it more powerful, you're going to put in more RAM. You're going to put in a faster hard drive. You're going to put in maybe an SSD hard drive. You're going to make a faster CPU chip. Whatever you need to do to that computer, you are making it more powerful. That is scaling up. However, if your one computer is maxed out, or if you don't have the means to scale up, you can also add more computers or copies of the database, and that is scaling out. So just think about a tabletop. If you scale out, you're adding more things to the tabletop. But if you're scaling up, you're keeping that one computer and making it more powerful. Now you can install your database on a couple of different places. You can install it locally, which means it's stored on these computers that you have in front of you, or you can store it on the cloud, which means that someone else manages that service. Regarding performance, a database is not measured in gigahertz or kilobytes or things like that. It's measured in input and output operations per second. It's called IOPS. It's the unit of measurement related to a storage device or related to our database. Now we're going to talk about database persistence, which is basically either you're storing it on a drive or you're storing it versus memory. If you have a database persistence with a memory, then what you're doing is you're reading and writing data to and from your RAM. And this is faster than reading and writing it from your disk. Instead of putting it onto your hard drive or onto your disk, you're doing it onto your RAM. That is your memory cache. Again, your cache is a temporary place that this memory is stored before it gets written over to the hard drive. You can also do, instead of your memory cache, you can put it on some sort of storage place, and whether it's persistent or non-persistent storage. Persistent storage is storing your database data on a local disk. So this puts it straight onto our hard drive, whether it be internal or external or whatever we're using. Or non-persistent storage is storing your database into your memory cache. And again, your memory cache is reading and writing it from the RAM. So the question is, do you want to put it onto your RAM or do you want to put it onto your disk? And really, those are our two options. We can also put it onto into the cloud, but that's putting it onto that hard drive in the sky, the disk. A couple ways your databases can be structured is that we want to make sure we use the database that provides our own solution. Now, you can either have a relational database or a NoSQL database, and we're going to talk about that on the next couple slides. Again, the location of this database just depends. You can have it on premises, you can have it locally or in the cloud, and really how you want to make sure your database is secure or safe is you encrypt the data both when it's resting, meaning not being used, and in transit, as it's being created, as it's being transferred over to the next place. Now, in terms of relational database versus NoSQL, let's talk about that in a minute. Sorry. We're going to use the database that provides our solution. Again, isolation is where database has its own network or on a shared network. However, you can also do horizontal scaling and vertical scaling, which again, means you're adding, horizontal means going out or adding more servers, more computers, whereas vertical is you're increasing the one computer to have a higher IOPS of individual database solutions. All right, now into relational and NoSQL. Relational databases use a structured blueprint called a schema of how data should be stored through field dimensions. These tables can be linked together using keys. You can either use a primary key or a foreign key. Primary key is a unique identifier within one table. I'm going to show you a graphic of this here in a minute. A foreign key is a unique identifier that can join related databases. Examples of these things are Oracle, MS SQL Server, MySQL, and PostgreSQL. Now this is a relational database. As you can see, these different kind of bubbles or windows are all linked together in some way, shape, or form. So over here on the left side, we've got the students. And these students are a primary key because each of these have different categories underneath it. Students is kind of our row or our record, and look at all these different fields within it. We have a student ID, we have the last name of the student, the first name of the student, the date of birth. This students is a primary key. And then over here on enrolled, this is our foreign key because it talks about student ID, class ID, and whether it's enrolled or not enrolled. And so this foreign key can join related databases together. Another primary key is classes and teacher. Class ID, class name, description, teacher ID. Teacher ID, last name, first name. So all of these have different rows and different fields, but the primary keys is a unique identifier within one table, whereas a foreign key is a unique identifier that joins related databases together. Now, along with that, we can also have no SQL. And no SQL does not follow a strict schema, but accepts unstructured data sources. The schema is less rigid compared to relational. It does offer more scalability compared to relational databases, and that is the nice thing about NoSQL. Now, it's kind of not as organized, and it will accept things that are not as structured, but you can often scale it a lot more. Some common NoSQL database types are key value databases, where a key is stored with the value. It contains different rows that have different types of data. You can also have a document NoSQL database, which uses documents like MS Excel, XML files, etc., to store and manage data. Multiple key values or documents can be stored in a single document. Examples of this are Oracle, NoSQL, MongoDB, and IBM Domino. So what do we do when we ever want to create a database? And we're going to talk about creating, reading, updating, and deleting database actions. And that's at the very bottom of the slide, called CRUD. Create, read, update, and delete database actions. So if you want to create a database, you can do it a couple different ways. You can do it manually. You would use create database as a command in a command line, or you can use GUI tools to do this. If it's scripted, you will create or acquire a script that will create a database and populate it with data. If it's a template, templates are ready to use in order to create our database. And these are common with cloud providers like Azure and AWS. We can also use a virtual machine image, a VM. It uses an image that already includes the database engine. It's mostly used in the cloud, but it's adding another database based on some sort of virtual machine image. Now, database connectivity, you can use manual or direct. You can access the database via GUI interface, and the commands such as SQL show, use, and select will help you to be able to do this. It is programmatic, which means it has a custom code, such as commands written in PHP. And these databases can be connected using a port number. If it's an MS SQL server, it uses TCP port 1433, but if it's a MySQL, it uses TCP port 3306. Database security, again, we obviously want anything that we deal with on a computer to be as secure as possible. There's some hardening techniques. Remember, hardening techniques are ways that make it more difficult for people to break in and look at your data. One of these is changing the default configuration settings of our database. You could also apply OS and database updates. You can enable anti-malware solutions, and you can also adhere to the principle of least privilege. What is that? The principle of least privilege, sometimes abbreviated as POLP, only gives permissions required to complete a task. Those should be granted and nothing more. So you're trying to find out, what do you want to do? Okay, I'm only going to allow you to do that and nothing more than this. You want to read a database? Okay, I'll let you read this, but you're not going to be able to change or create or edit or delete anything. A database does have some transmission hardenings as well. If you want, whenever you're transmitting a database and you want to harden that transmission, you can either use a VPN, which is a virtual private network, or you can encrypt the traffic either using a couple encryption tools like TLS or TDE. And make sure you do insist on using secure passwords for your users. If these are just simply password 123, it's not very secure and people can get into your database. So make sure each of your users that are accessing the database do use some secure passwords. So you've created a database and we need to manipulate the database or try to add or edit the database. Again, you can use either GUI, graphic user interface, and command line tools. Really depends on what OS that you're using and what you're comfortable with. You do have some validation rules for fields where only the proper data is allowed. And there are query tools such as select that will allow you to manipulate the data. But if you want to get data into your databases, you typically are going to manually enter that data. You could import a supported file, such as a CSV file or a backup file. You could transfer locally or over the internet. You can put in a command of insert into as a relational database command, or update as a relational database command, or you can just simply update your queries, and this will get data into your database. As your database grows, odds are your performance will slow. So to fix this, you want to do two things. You want to remove infrequently accessed data. As you continue to create a database, there's going to be data in there that is not as important as others. So you want to remove that. And you can also create an index for queried data. You can create an index, which means it's going to be quicker for you to search for the most common searches. That way, it's only finding the things that are important. Now, common data removal and backup methods would include manual data deletion, automated archiving. You could delete your queries, or you could export a database dump to a file. And then you do have a couple query and report builder tools. Once you have it, the reason you have a database is so you can look at your numbers and look at what you're dealing with and understand how to do things better. So getting some sort of search or some sort of report back is going to be very helpful. Most databases provide query and report building tools that are GUI based. And you can customize the data entry points and headers into the report. It makes it easy to be able to look at and see a really nice version of what you're trying to find. All right, so that is it with chapter 14, which deals with understanding databases. We're going to go through some review questions. As always, again, this is a brand new topic for U61, so feel free to do a little bit more research. I know that when you look at the breakdown of the U61 exam, it doesn't show it to be really large in terms of the number of questions, but when I took this exam, I remember quite a few database questions within the exam. So make sure you look at this and understand your database as best you can. There's a lot of resources out there on YouTube or in Google that you could search that will also help you understand databases a little bit more. But you don't have to go too in depth. Just a basic understanding of databases. A lot of the terminology is going to be very important as you take your exam. So study up and research as best you can. All right, let's look at our review questions here. I've got 10 of these that cover chapter 14. Chapter 14 review questions. What is another term used to refer to a field? A, row, B, collection, C, column, D, foreign key. We talked about how record and row go together, both R's, so field would go with column. So again, record, row go together, therefore the field column go together. Number 2, your database has grown over time and you need to improve query performance. What should you do? Choose 2. A, perform a database dump. B, remove infrequently accessed data. C, create an index for queried data. D, create a foreign key. If it has grown over time and things are slowing down, this is one of the last things we talked about in the PowerPoint, is you do want to remove infrequently accessed data to only give you the most important things there, or you can, or you can create an index for the things that you query the most. So it's B and C. Number 3, you have increased the amount of RAM available for your cloud-based database instance. Which term describes this action? A, scaling in, B, scaling down, C, scaling out, D, scaling up. Remember, you are adding RAM. That is not adding computers. You are making your one computer more powerful. So that is scaling up, D. If you're adding more computers or more servers or more cloud-based devices, that would be scaling out. Number 4, you have increased the number of computer nodes for your cloud-based database instance. Which term describes this actions? And on that one, a computer node is just more than one computing device for your cloud-based things, and so that is an example of scaling out. Number 5, you have configured a database in the headquarters office located in Houston, Texas. Your company has offices in major cities across Canada and the United States. Users in Eastern Canada complain about slow query access to the database, while Texas users enjoy fast performance. What should you do? A, place a read replica in Eastern Canada. B, create an index. C, place a writable replica in Eastern Canada. D, create a foreign key. So the problem is that our database is located in Texas, but people in Canada can't get to it fast enough because of how far away that it goes. They don't need to do anything other than look at this database, and they have slow query access. You can't look at it and you can't pull any results to it. They don't necessarily need to add to it or modify it. They just want to be able to look at it and pull results. So the best course of action in this case is to place a read replica in Eastern Canada. A read replica compared to a writable replica is where read is they just have to look at it and do what they need to do. Writable is where they actually combine, add things to it, modify it, possibly delete things, just depends. So 5 is A. Number 6, which unit of measurement relates to disk throughput? A, megahertz, B, gigahertz, C, IOPS, D, uptime. Disk throughput regarding the database is our IOPS, input output per second. Number 7, which type of database does not use a rigid schema? A, relational, B, on premises, C, cloud, D, no SQL. Remember, one of these does use a schema or a blueprint, the other one does not, or does not use a rigid schema or blueprint. And the one that's less structured is our no SQL. Number 8, which type of database does use a rigid schema? A, relational, B, on premises, C, cloud, D, no SQL. If no SQL does not use a rigid schema, then the other one that does is relational. Number 9, what statement regarding no SQL databases are correct? Choose 2. A, each row must store the same amount of data. B, they are less scalable than relational databases. C, each row can store different types of data. D, they are more scalable than relational databases. Remember, the benefits of a no SQL compared to a relational is that you can store, it's less structured, so you can store different types of data, and also the benefit, because it's less structured, is you can scale it more than a relational. So it is C and D. And finally, number 10, which of the following is a no SQL database? A, Microsoft SQL Server, B, Mongo database, C, Oracle database, D, MySQL. A no SQL would not have SQL in it, so we definitely know it's not A and it's not D. Of the other two, just knowing from our PowerPoint that we talked about, the one that's a no SQL is Mongo database. All the rest of these are considered relational databases. All right, that's it for Chapter 14, dealing with understanding databases. Feel free to review the video at your own leisure. As always, leave any comments down below. If you have any questions or comments, I'm happy to reply. And we will come back for one more video for Chapter 15, which closes out our video series. Thanks for watching, and as always, keep on keeping on.